happen when massive stars die, and they notice something strange. These bursts seem to be clustered in specific regions. What if I told you the universe itself holds breathtaking wonders, spanning across light years, that defy imagination? From phenomena that warp time to structures so colossal they challenge our understanding of space. The cosmic web is home to some of the most awe-inspiring marvels ever discovered. Ready to unravel the mysteries of the cosmos? Join us as we explore 7 jaw-dropping wonders of the cosmic web. The Hercules Corona Borealis Great Wall. Imagine a structure so colossal that it takes your brain a moment to grasp its sheer size. A cosmic masterpiece stretching 10 billion light-years across. Meet the Hercules Corona Borealis Great Wall, the largest known structure in the universe. Now, when we talk about large, we're not just comparing it to planets or galaxies. We're talking about something so vast that light itself, the fastest thing we know, takes billions of years to travel its length. This isn't just a cluster of galaxies. It's a chain of galaxies bound together in a formation so massive it challenges everything we thought we knew about the cosmos. So how was this megastructure discovered? Astronomers were studying gamma-ray bursts, those incredible explosions that happen when massive stars die, and they noticed something strange. These bursts seemed to be clustered in specific regions of the sky, which hinted at the presence of a hidden cosmic giant. Further observations revealed this colossal wall of galaxies, stretching so far that it's nearly impossible to comprehend. It's like finding a mountain range that spans a third of the universe itself. Seriously, just try to picture that for a moment. 10 billion light-years of galaxies, stars, and untold mysteries. What's really wild is that this Great Wall doesn't fit neatly into the theories we have about how the universe is structured. According to the cosmological principle, the idea that the universe is uniform on the largest scales, something this big shouldn't even exist. Its discovery has forced scientists to rethink the rules of the game. Why would matter arrange itself into something so immense? What forces could shape such a structure? It's like the universe decided to flex its creative muscles and say, "Think you've got it all figured out? Guess again." But the Hercules Corona Borealis Great Wall isn't just a jaw-dropping factoid. It's a portal to bigger questions. It's a reminder of how much we don't know about the universe. Structures like this aren't just about their size. They're about the story they tell. They hold clues to the early days of the universe, the mysterious forces shaping it, and maybe even the future of everything we know. So next time you look up at the stars, remember, somewhere out there, far beyond what we can see, lies a wall so vast it redefines what we thought was possible. Mind-blowing, right? The cosmic microwave background. Take a moment to imagine the faintest whisper of a story, left over from the very birth of the universe. That is the cosmic microwave background, or CMB for short. It is not just any light, it is the oldest light in existence, a relic from a time when the universe was just 380,000 years old, a baby, cosmically speaking. This faint glow is everywhere in the sky, a subtle reminder of the Big Bang that kick-started everything we see today. It is like holding a photograph of the universe as an infant, showing us what things looked like before galaxies, stars, and planets even existed. Now here is where it gets exciting. This glow is not uniform. It has tiny variations, little ripples in its temperature, that tell us where the seeds of galaxies and clusters formed billions of years ago. Think of it like cosmic breadcrumbs, showing the early layout of the universe. When scientists mapped these variations using missions like WMAP and Planck, they unlocked a treasure trove of information. It is through these maps that we learned about the universe's age, its composition, and how much of it is made up of mysterious things like dark matter and dark energy. Can you believe that a faint glow in the sky holds answers to some of the biggest questions in cosmology? What makes the CMB truly incredible is its universal presence. No matter where you look in the sky, this ancient light is there. It connects everything, every star, galaxy, and atom, to a single origin. It is humbling to think that this glow has traveled for over 13 billion years, untouched and uninterrupted, just to reach us. And the best part? It is still teaching us new things. Every time scientists look deeper, they discover more clues about the universe's early days and the forces that shaped its evolution. At the end of the day, The cosmic microwave background is more than just an astronomical phenomenon. It is a time capsule, a glimpse into the universe's fiery beginnings, and a reminder of how interconnected everything truly is. So the next time you stare up at the night sky, think about this. That glow is not just the stars or the Milky Way. It is the universe's first light, still echoing through the cosmos, carrying the story of how everything began. Amazing, right? The Sloan Great Wall. Picture a wall in the cosmos so massive it would take light over 1 billion years to travel across it. That is the Sloan Great Wall, one of the largest cosmic structures ever discovered. It is not a wall in the traditional sense, but a sprawling chain of galaxy clusters, filaments, and voids woven into the fabric of the universe. This awe-inspiring structure stretches over 1.37 billion light-years and completely redefines what we thought was possible when it comes to scale in the universe. What makes the Sloan Great Wall so fascinating is how it was uncovered. Astronomers mapping the positions of galaxies through the Sloan Digital Sky Survey stumbled upon this enormous arrangement, almost by accident. Imagine zooming out on a cosmic map and suddenly seeing this intricate network of galaxies connected like threads in a spider's web. The discovery was groundbreaking. It showed us that galaxies do not randomly scatter throughout space. Instead, they follow patterns shaped by gravity and the mysterious forces of dark matter. You might be wondering why this giant cosmic wall is such a big deal. Here is the thing. It challenges one of the fundamental ideas about the universe, the cosmological principle. This principle says the universe should look more or less the same on a large scale, no matter where you look. But something as colossal as the Sloan Great Wall seems to defy that idea. How could such a massive structure exist without breaking the rules of cosmic formation? It forces scientists to rethink how the universe organizes itself, and raises fascinating questions about the very nature of reality. When you think about it, the Sloan Great Wall is not just a scientific discovery. It is a reminder of how vast, interconnected, and mysterious the universe truly is. It is proof that even the biggest questions do not have easy answers, and that there is always more to learn. So the next time you hear about the mysteries of space, remember that structures like this one are waiting out there, quietly holding secrets about the cosmos. Mind-blowing, isn't it? The Virgo supercluster. Think about this for a moment. The Milky Way, our galactic home, is just one of countless galaxies nestled within an immense cosmic structure called the Virgo supercluster. Stretching roughly 110 million light-years across, this supercluster is our celestial neighborhood, a vast network of galaxies all bound together by gravity. It is where we belong in the grand cosmic web, and understanding it gives us a deeper connection to the universe itself. What is so cool about the Virgo supercluster is how it influences the motion of galaxies, including our own. At its heart lies the Virgo cluster, a dense hub of thousands of galaxies with a gravitational pull so strong that it dictates the paths of galaxies even millions of light years away. Picture an intricate dance where galaxies move in complex patterns, all choreographed by the gravity of this massive cluster. Our own Milky Way is part of this grand movement, heading toward a region known as the Great Attractor, another mysterious point of gravity in our universe. One of the most fascinating things about studying the Virgo supercluster is how much it has taught us about the invisible side of the universe. When scientists map the motions of galaxies, they can detect the presence of dark matter, the unseen substance that makes up most of the universe's mass. The Virgo supercluster is like a giant lab, helping us uncover the secrets of how dark matter shapes cosmic structures. Without dark matter, none of these incredible formations, from galaxies to superclusters, would exist. In the end, the Virgo supercluster is more than just a collection of galaxies. It is a reminder that even in the vastness of space, there is a sense of structure and belonging. Our galaxy is part of something far larger, a network of stars and planets bound together across unimaginable distances. So when you look up at the stars, remember you are connected to this colossal supercluster, a tiny piece of a cosmic masterpiece that is still being unraveled. Inspiring, isn't it? The Boots Void. Have you ever thought about what lies in the emptiest corners of the universe? That is where the Boots Void comes in. It is not just empty, It is a staggering 330 million light-years of near-total nothingness, earning it the nickname the Great Nothing. When astronomers first discovered it, they were stunned. How could a region of space so vast have so few galaxies, when the rest of the cosmos seems packed with them? It is a mystery that still sparks debates and theories to this day. What makes this void so puzzling is how much it breaks the pattern of the universe. Space is not supposed to be perfectly uniform, but it is typically filled with clusters of galaxies connected by filaments, all forming the intricate cosmic web. Yet the Bouteille's void is almost completely empty, with only a handful of galaxies scattered across an area that could normally hold tens of thousands. It is as if the universe just decided to take a break here, leaving behind an eerie void of unimaginable size. The best part about the Boots void is how it challenges everything we thought we knew about galaxy formation. Scientists believe voids like this are created when regions of space run out of material to form stars and galaxies. But the sheer size of this one suggests there is more to the story. Some even speculate about exotic explanations like alternative physics or phenomena we have yet to discover. It is like the universe's version of a blank canvas, inviting us to imagine what might exist or not exist within its depths. What is really fascinating is how the Boots void reminds us of the universe's diversity. While we are amazed by clusters of galaxies and grand cosmic structures, voids like this one are just as important. They shape the web of the universe and tell us that even emptiness has a role to play in the grand design of space. So the next time you hear about the mysteries of the cosmos, think about the Boots void, a silent and enigmatic stretch of space that keeps us questioning and searching for answers. Amazing, right? The Laniakea supercluster. Can you imagine the sheer size of the cosmic neighborhood we call home? Let me introduce you to the Laniakea supercluster, a structure so vast it redefines what we call home in the cosmos. This supercluster contains around 100,000 galaxies, including our Milky Way, and stretches over 520 million light-years. The name Laniakea, which means immeasurable heaven in Hawaiian, perfectly captures the breathtaking enormity of this region. It is the very definition of cosmic scale. What makes Laniakea truly special is how interconnected it is. Think of it as a sprawling network of galaxies flowing like rivers along invisible filaments of gravity. At the heart of this supercluster lies a gravitational basin called the Great Attractor, a region pulling everything toward it, including our galaxy. When scientists mapped Laniakea in 2014, they used the motions of thousands of galaxies to trace the edges of this colossal structure. What they found was a massive web where everything was drawn toward this central point, creating a cosmic dance of unimaginable proportions. Here's where it gets even cooler. Laniakea is not just a single, isolated structure. It is part of the larger cosmic web, where superclusters like Laniakea are interconnected across billions of light-years. This means that our supercluster is just one thread in the universe's grand tapestry. By studying how galaxies move within Laniakea, scientists have gained insights into the mysterious forces shaping the universe, like dark matter and dark energy. It is like unraveling the secrets of the cosmos one step at a time. When you step back and think about it, Laniakea is more than just a collection of galaxies. It is a reminder of how small we are in the grand scheme of things, yet how connected we are to something much larger. Our Milky Way is part of this enormous supercluster, tied together with countless other galaxies, all moving in harmony. It is a stunning example of the beauty and complexity of the universe. Mind-blowing, isn't it? The cosmic web itself. Let's take a step back and think about the universe on the biggest scale possible. The cosmic web is exactly that, the largest structure in existence, connecting galaxies, clusters, and superclusters across billions of light-years. Picture a three-dimensional web stretching out in every direction, with luminous threads where galaxies gather and vast empty voids in between. This is the very framework of the universe, the invisible scaffolding that holds everything together. What makes the cosmic web so fascinating is how it was formed. It all started after the Big Bang, when tiny fluctuations in the early universe grew over time under the pull of gravity. Dark matter, the mysterious substance we still do not fully understand, played a huge role in shaping this web. Galaxies formed along these dark matter filaments like beads on a string, while the spaces between them stretched into massive voids. When you think about it, this web is like the universe's fingerprint, a unique and intricate design that tells the story of how everything we see came to be. You might wonder how we even know this web exists. Thanks to incredible advances in technology and simulations, astronomers have been able to map the cosmic web by tracking the distribution of galaxies and the gas that fills the spaces between them. One way they do this is by studying quasars, the super-bright centers of distant galaxies. As light from these quasars passes through the universe, it interacts with hydrogen gas in the web, leaving behind clues about the web's structure. It is like piecing together a puzzle that spans billions of light years. When you think about the cosmic web, it is not just an abstract idea. It is a profound reminder of how connected everything truly is. Every galaxy, every star, and every planet is part of this vast and intricate network, shaped by forces that have been at work for over 13 billion years. It is the ultimate proof that the universe is not random but carefully organized on scales so massive they boggle the mind. As we conclude our journey through the 7 wonders of the cosmic web, we're reminded of the universe's awe-inspiring beauty and complexity. These celestial marvels push the boundaries of our knowledge and fuel our curiosity to explore the unknown. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us. Ever wondered what mysteries lie beyond the blue horizon of Neptune? From its supersonic winds to its hidden ocean of liquid water, this distant giant planet is full of astonishing surprises. Neptune, the 8th planet from the Sun, remains one of the most enigmatic members of our solar system. What makes it so unique, and why does it capture our imagination? Join us for an incredible journey into the heart of Neptune's wonders, where science meets the extraordinary in a world of blue. Neptune is a windy wonderland. Neptune is a planet of extremes, and its winds are no exception. This gas giant holds the title for the fastest winds in the solar system, with speeds reaching up to 1,200 miles per hour. That's nearly 5 times faster than the strongest hurricanes on Earth. These incredible winds create a dynamic and chaotic atmosphere, with giant storms and dark spots moving across the planet's surface. The planet's winds are fueled by Neptune's internal heat, which radiates more energy than it receives from the Sun. This heat drives massive convection currents, creating powerful jet streams and vortices that rage across the atmosphere. These winds give Neptune its ever-changing weather patterns, despite its frigid distance from the Sun. One of the most famous weather features on Neptune was the Great Dark Spot, a storm system the size of Earth. Discovered by the Voyager 2 spacecraft in 1989, this giant storm vanished just a few years later, showcasing the dynamic nature of Neptune's atmosphere. Scientists are still studying what makes Neptune's winds so extreme. The planet's unique combination of internal heat, atmospheric composition, and rapid rotation all play a role, but the exact mechanisms remain a mystery. The winds of Neptune are a testament to the raw power of planetary weather, offering a glimpse into a world where nature reigns supreme. The deep blue mystery of Neptune's color. Neptune's striking blue color is one of its most defining features, but it's not just a simple reflection of the sky. This rich azure hue comes from methane in the planet's atmosphere, which absorbs red light from the sun and reflects blue light back into space. However, methane alone doesn't fully explain Neptune's intense coloration. Scientists believe that there are other, unknown components in the atmosphere that enhance the blue tone. These mystery molecules have yet to be identified, making Neptune's appearance as much a scientific puzzle as it is a visual marvel. Neptune's vivid blue sets it apart from its neighbor Uranus, which also contains methane but appears a paler shade of blue-green. The subtle differences in atmospheric composition between these two planets highlight just how unique Neptune truly is. The planet's color isn't just an aesthetic feature, it provides valuable clues about the composition and chemistry of its atmosphere. By studying Neptune's blue, Scientists gain insights into the processes at work on this distant world, and even on exoplanets that share similar characteristics. Neptune's mesmerizing blue reminds us of the beauty and complexity of our solar system, where even the color of a planet holds untold secrets. The discovery of Neptune was a mathematical marvel. Neptune's discovery in 1846 wasn't a stroke of luck, it was a triumph of mathematics and astronomy. Scientists noticed that the orbit of Uranus wasn't following predictions, suggesting the gravitational pull of an unseen planet. Using calculations, French mathematician Urbain Le Verrier pinpointed Neptune's position without ever looking through a telescope. When German astronomer Johann Galle aimed his telescope at the predicted spot, Neptune was there, just as Le Verrier had calculated. This marked the first time a planet was discovered through mathematical prediction rather than direct observation, a breakthrough that changed the course of astronomy. Interestingly, English mathematician John Couch Adams had also made similar calculations around the same time, leading to a controversy over who deserved credit for Neptune's discovery. In the end, both Le Verrier and Adams are recognized for their contributions. Neptune's discovery also underscored the power of Newton's laws of motion and universal gravitation, which formed the basis of the calculations. This event cemented the idea that mathematical models could predict the existence of celestial objects, a concept that continues to guide modern astronomy. The discovery of Neptune stands as a testament to human ingenuity, showing how the mind can uncover worlds hidden from the eye. Neptune's rings are thin and wispy. Neptune is adorned with a set of faint, thin rings that add to its otherworldly charm. These rings, made of dust and ice particles, are far more delicate and less prominent than those of Saturn. There are 5 main rings: Gale, Le Verrier, Lassell, Arago, and Adams, each named after notable scientists who contributed to our understanding of the planet. What makes Neptune's rings unique is their clumpy and uneven distribution, a phenomenon scientists are still trying to understand. Some parts of the rings appear brighter and denser, forming arcs rather than smooth, continuous bands. These arcs are thought to be stabilized by the gravitational pull of Neptune's moons, particularly Galatea. The rings were first detected in the mid-1980s through ground-based observations and were later confirmed by the Voyager 2 spacecraft. Voyager's flyby provided detailed images of the rings, revealing their complex structure and composition. Despite their faintness, Neptune's rings hold valuable information about the planet's history and the processes that shaped its outer regions. By studying the rings, scientists hope to uncover clues about the formation of the outer solar system and the interactions between moons and planetary rings. Neptune's rings may not be as famous as Saturn's, but they are a delicate reminder of the intricate beauty found throughout the cosmos. Neptune is an ice giant with a hidden ocean. Neptune belongs to a category of planets known as ice giants, which are distinct from gas giants like Jupiter and Saturn. Beneath its thick atmosphere lies a mantle of water, ammonia, and methane ice, creating an interior vastly different from the gas giants. This icy composition gives Neptune its classification, but it also raises intriguing possibilities. Scientists believe that under the icy mantle lies a vast ocean of superheated, high-pressure water. This ocean, kept in a liquid state by extreme pressure, could potentially harbor exotic forms of life or unusual chemical processes. Neptune's core is a rocky mix of silicates and metals, surrounded by this mysterious ocean. The transition from the icy mantle to the core is gradual, creating a layered structure that adds to the planet's complexity. The pressure and temperature in Neptune's interior are so extreme that methane molecules could break apart, forming diamonds. These diamonds might sink to the core, creating a glittering layer of solid carbon, a phenomenon often referred to as the diamond rain. Neptune's status as an ice giant with a hidden ocean sets it apart as a planet full of surprises, challenging our understanding of what a world can be. Neptune's moons are a diverse family. Neptune is home to 14 known moons, each with its own unique characteristics. The largest and most famous is Triton, a fascinating moon with a retrograde orbit, meaning it orbits Neptune in the opposite direction of the planet's rotation. This unusual motion suggests that Triton was likely captured from the Kuiper Belt, a region of icy objects beyond Neptune. Triton is a world of wonders, featuring geysers that spew nitrogen gas, a thin atmosphere, and a surface covered in frozen nitrogen and methane. Its geologically active surface makes it one of the most intriguing moons in the solar system, and a prime candidate for future exploration. In contrast to Triton's icy splendor, Neptune's smaller moons are less dynamic but no less interesting. Proteus, the second largest moon, is oddly shaped and heavily cratered, suggesting it has remained relatively unchanged for billions of years. Nereid, another notable moon, has one of the most eccentric orbits of any moon, swinging dramatically closer and farther from Neptune. These moons offer a glimpse into the diverse processes that shape planetary systems. Some moons are likely remnants of Neptune's original satellite system, while others, like Triton, are later additions. Studying them helps scientists understand how moons form and evolve over time. Neptune's moons are a microcosm of the solar system's complexity, each contributing to the rich tapestry of this distant planet. Neptune's magnetic field is misaligned and tilted. Neptune's magnetic field is unlike any other in the solar system. It's both off-center and tilted at a staggering 47 degrees relative to the planet's rotational axis. This means that Neptune's magnetic field is constantly shifting, creating a wildly dynamic magnetosphere. The magnetic field is generated by electric currents within the planet's icy mantle, rather than in a metallic core as on Earth. This difference in origin contributes to its unusual properties, including its irregular shape and strength. In some regions, Neptune's magnetic field is up to 10 times stronger than in others. This chaotic magnetic field produces spectacular auroras, much like the northern and southern lights on Earth. However, Neptune's auroras are more scattered and less structured, appearing as patches of glowing light near the poles. The planet's unique magnetosphere also interacts with the solar wind in ways that are still not fully understood. Voyager 2 provided the first glimpses of Neptune's magnetic behavior, but many questions remain about how it affects the planet and its surrounding space environment. Neptune's magnetic field adds another layer of intrigue to this distant world, highlighting the diverse ways planets generate and sustain magnetic forces. Neptune's year lasts 165 Earth years. A year on Neptune is an extraordinary 165 Earth years long, meaning it takes nearly 2 centuries to complete one orbit around the Sun. Since its discovery in 1846, Neptune has completed just one full orbit, which occurred in 2011. This lengthy year is due to Neptune's vast distance from the Sun, about 30 times farther than Earth. At this distance, the Sun appears much smaller in Neptune's sky, providing only a fraction of the light and warmth that reaches our planet. Despite its slow orbit, Neptune rotates rapidly on its axis, completing a day in just 16 hours. This rapid spin, combined with its elliptical orbit, creates fascinating seasonal variations. Each of Neptune's 4 seasons lasts more than 40 Earth years, resulting in gradual but significant changes in atmospheric activity. Understanding Neptune's lengthy year and slow seasonal shifts provides valuable insights into the dynamics of planetary orbits and climate systems. The planet's orbit also places it in a region of the solar system that offers clues about the formation of outer planets and the migration of celestial bodies. Neptune's epic year serves as a reminder of the vast scales of time and distance that define the outer reaches of the solar system. Neptune was the last stop for Voyager 2. In 1989, NASA's Voyager 2 spacecraft became the first, and so far only probe to visit Neptune. This historic flyby provided humanity's closest look at the distant planet, revealing breathtaking details about its atmosphere, moons, and rings. Voyager 2 captured stunning images of Neptune's vibrant blue clouds, powerful storms, and faint rings, transforming our understanding of the planet. It also made groundbreaking discoveries, such as the presence of the Great Dark Spot, the dynamic weather patterns, and Triton's geysers. The spacecraft's instruments measured Neptune's magnetic field, confirming its tilted and off-center configuration. Voyager 2 also provided data on the planet's temperature, wind speeds, and atmospheric composition, laying the foundation for future studies of ice giants. Voyager 2's flyby lasted only a few hours, but its legacy endures. The mission's data continues to inform scientific research and inspire new questions about Neptune and its role in the solar system. The encounter with Neptune marked the end of Voyager 2's planetary tour, but the spacecraft remains a symbol of humanity's quest for knowledge, now traveling through interstellar space as a messenger of discovery. Neptune may hold clues to the formation of exoplanets. Neptune's status as an ice giant makes it a valuable analog for studying exoplanets, planets beyond our solar system. Many of the exoplanets discovered so far are Neptune-like in size and composition, falling into a category known as mini-Neptunes or sub-Neptunes. By studying Neptune, scientists can better understand the atmospheric processes, magnetic fields, and interior structures of these distant worlds. Neptune's dynamic weather, deep blue hue, and icy mantle offer a template for modeling the conditions on similar exoplanets. One of the most intriguing aspects of Neptune-like exoplanets is their potential habitability. While Neptune itself is inhospitable, its characteristics help researchers identify which exoplanets might have liquid water, stable atmospheres, or conditions suitable for life. Future missions to study Neptune up close, such as orbiters or atmospheric probes, could provide critical data for interpreting observations of exoplanets. These missions would also deepen our understanding of how planets like Neptune form and evolve in different stellar systems. Neptune's connection to exoplanet research highlights its importance not just as a member of our solar system, but as a key to unlocking the mysteries of the universe. Neptune is a planet of mysteries, extremes, and beauty, offering a glimpse into the farthest reaches of our solar system. From its supersonic winds to its hidden ocean, Neptune continues to captivate scientists and dreamers alike. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the wonders of the universe with us. Have you ever gazed up at the night sky and wondered what bizarre, otherworldly places might be out there? The universe is filled with exoplanets so strange and extreme that they defy imagination. From planets hotter than stars to worlds made entirely of ice, these discoveries redefine what we thought was possible. Join us as we take a journey to explore the 10 strangest exoplanets discovered so far. Each one will blow your mind, so stick around and let's dive into the cosmos together. Kelt 9b, a scorching inferno. Meet Kelt 9b, a planet so blisteringly hot it challenges the boundaries of planetary science. Orbiting a star twice as hot as our Sun, this gas giant experiences daytime temperatures exceeding 7,800 degrees Fahrenheit. That's hotter than some stars. The extreme heat has stripped the planet of its atmosphere's molecules, breaking them down into their basic atomic components. This planet orbits so close to its host star that a year lasts only about 1.5 days. Its proximity causes it to be tidally locked, meaning one side is perpetually facing the scorching star while the other remains in darkness. Scientists speculate that the night side might be slightly cooler, but cooler is relative when the entire planet is engulfed in unrelenting heat. What makes Kelt 9b even more extraordinary is that it's gradually evaporating. The intense radiation from its star is blowing its atmosphere away into space, creating a glowing tail, much like a comet. This phenomenon provides astronomers a rare glimpse into atmospheric escape, a process that's reshaping our understanding of planetary evolution. Traveling to Kelt 9b isn't an option, it's inhospitable beyond imagination, but studying it reveals how diverse and extreme planets in our universe can be. It's a fiery example of how exoplanets push the limits of what we consider possible in the cosmos. Gliese 436b, the ice on fire world. Gliese 436b seems like a contradiction of nature. Imagine a planet covered in burning ice. Located about 30 light-years away, this Neptune-sized world defies expectations with its bizarre mix of heat and ice. Its surface temperature is a scorching 800 degrees Fahrenheit. Yet water exists as a solid ice mantle, compressed by the planet's immense gravity. This scorching world has a thin atmosphere, primarily composed of hydrogen, helium, and methane, which traps heat. Despite the intense temperatures, the high pressure on the planet keeps water locked in a strange, solid state called hot ice. This exotic form of water remains stable even under extreme heat, an incredible reminder of how physics behaves differently in alien worlds. Adding to the intrigue, Gliese 436b completes an orbit around its host star in just 2.6 Earth days. This tight orbit means the planet is exposed to constant stellar radiation, which further accentuates the paradox of its fiery, ice-covered surface. This otherworldly discovery shows how diverse exoplanets can be, challenging our understanding of what's scientifically possible. Gliese 436b is a testament to the universe's endless creativity, blending fire and ice in a way that can only exist far beyond our solar system. HD 189733b, the glass rain planet. Known as Osiris, HD 209458b is a gas giant slowly being ripped apart by its parent star. Located 150 light-years away, this exoplanet is losing its atmosphere to space at an astonishing rate due to its proximity to its host star. It's a perfect example of a hot Jupiter, a gas giant orbiting extremely close to its star. Osiris experiences extreme ultraviolet radiation that heats its atmosphere, causing hydrogen and helium to escape into space. This process forms a massive tail of gas trailing behind the planet, making it resemble a comet more than a traditional planet. This tail stretches thousands of miles and offers a fascinating glimpse into planetary disintegration. Astronomers have even detected heavier elements like oxygen and carbon in the escaping atmosphere. This discovery is groundbreaking, as it allows scientists to analyze the chemical composition of an exoplanet's atmosphere in detail. The fate of Osiris provides an eerie glimpse into the potential endgame for other exoplanets orbiting too close to their stars. It's a powerful reminder of the delicate balance planets must maintain to survive the harsh realities of space. Kepler 16b, the Tatooine planet. Kepler 16b is a real-life version of Tatooine from Star Wars, a planet that orbits not one but two stars. This celestial oddity is located about 200 light-years away and is a gas giant roughly the size of Saturn. Its dual suns create a surreal, ever-changing skyline that alternates between single and double sunsets. The planet lies in a circumbinary orbit, meaning it revolves around both stars as they dance together in a cosmic waltz. Despite its dramatic skies, Kepler 16b is surprisingly cold, with temperatures averaging around -100 degrees Fahrenheit. This chill is due to the distance from its host stars, which provide just enough light to illuminate its surface without warming it significantly. Kepler 16b's discovery confirmed that planets can form and survive in binary star systems, a finding that expands the possibilities for where planets might exist in the universe. This revelation has inspired scientists to explore the dynamics of binary systems further, opening the door to more discoveries in the future. Though uninhabitable, Kepler 16b sparks the imagination with its resemblance to science fiction worlds. Its existence proves that the universe holds surprises beyond anything we could dream up in fiction. 55 Cancri E, the lava world. 55 Cancri E is a planet of extremes. Found 41 light-years away in the Cancer constellation, this rocky super-Earth is locked in a perpetual furnace. With one side permanently facing its star, the planet experiences temperatures soaring over 4,400 degrees Fahrenheit. On the other side, where starlight never reaches, temperatures plummet drastically, creating a world of stark contrasts. This hellish planet is theorized to have rivers of lava flowing on its day side. Its surface glows with molten rock, illuminated by its blistering star. Scientists also suspect that the planet's atmosphere is dense with vaporized minerals, adding to its fiery ambience. The interaction between the extreme heat and the planet's unique geology creates an environment where lava oceans could exist, constantly churning and reshaping the surface. What makes 55 Cancri E even more captivating is its unusual orbit. A year on this planet lasts only 18 Earth hours, meaning it hurtles around its star at breakneck speeds. The extreme proximity to its host star also causes significant tidal heating, contributing to its molten state and making it an active and volatile world. As bizarre as 55 Cancri E sounds, its study offers scientists valuable insights into planetary formation under extreme conditions. This lava world is a testament to how planets can evolve into scorching wastelands that challenge our perceptions of habitability. WASP 12b, the planet being consumed. WASP 12b is a doomed world, slowly being devoured by its host star. Located about 1,400 light-years away, this gas giant orbits perilously close to its star, completing an orbit in just over 1 Earth day. Its proximity subjects the planet to immense gravitational and radiation forces, causing its atmosphere to stretch and form an elongated shape rather than the typical spherical form of planets. The intense radiation from the star heats WASP-12b to temperatures around 4,000 degrees Fahrenheit, making it one of the hottest known exoplanets. This heat has caused the planet's outer layers to expand and leak into space, forming a trail of escaping gases. Essentially, WASP-12b is being consumed alive, losing about 189 quadrillion tons of material every year. Astronomers studying this phenomenon have likened it to a celestial version of vampirism, where the host star is draining the planet of its lifeblood. Over time, this will result in WASP-12b being entirely obliterated, leaving nothing but a ghostly ring of debris around the star. This dramatic process offers a rare glimpse into planetary destruction, a stage in the life cycle of planets that's difficult to observe directly. WASP-12b's tragic fate reminds us of the fragile balance planets must maintain to survive the harsh realities of space. TRES 2b, the darkest planet. TRES 2b, located about 750 light-years from Earth, is often called the Black Planet due to its astonishing ability to absorb light. This gas giant reflects less than 1% of the starlight that hits it, making it darker than coal. Despite being bathed in the light of its host star, the planet remains eerily dark, with only a faint red glow caused by its internal heat. The reason for TRES 2b's darkness lies in its unusual atmosphere, which lacks reflective clouds and is rich in light-absorbing chemicals like titanium oxide. These compounds trap heat and light, giving the planet its pitch-black appearance. The lack of an atmosphere capable of scattering light further enhances its shadowy nature. Although it's cloaked in darkness, TRES 2b is incredibly hot, with temperatures soaring to over 1,800 degrees Fahrenheit. The stark contrast between its searing heat and its inky blackness makes it one of the most intriguing exoplanets ever discovered. Scientists are still unraveling the mystery of why TRES 2b is so exceptionally dark. Studying it could provide insights into atmospheric compositions and help identify similar worlds in the future. TRES 2b is a haunting reminder of how alien and diverse planets beyond our solar system can be. PSRB 16 2026 b Methuselah, the ancient planet. Nicknamed Methuselah for its incredible age, PSRB 162026 b is the oldest known planet in the universe, with an estimated age of 12.7 billion years. That's nearly 3 times the age of Earth. Orbiting a binary system composed of a pulsar and a white dwarf, Methuselah is located in the globular cluster M4, about 12,400 light-years away. This gas giant challenges everything we know about planetary formation, as it emerged when the universe was less than 1 billion years old and lacked many of the heavier elements needed to form planets. Its existence suggests that planets can form under a broader range of conditions than previously thought. Methuselah's orbit around its host stars is both stable and extraordinary, taking about 100 Earth years to complete. This leisurely pace offers scientists a fascinating opportunity to study the gravitational interactions within its unique binary system. Despite its ancient origins, Methuselah is a robust planet that has endured countless cosmic events, including nearby supernovae and the gradual aging of its host stars. It's a true survivor, offering a window into the universe's earliest days. HD 189733b, the glass rain planet. HD 189733b, a stunningly violent world, is located 64 light-years away in the constellation Vulpecula. This gas giant has an atmosphere dominated by silicate particles, which condense to form clouds of molten glass. The result is a planet where it literally rains glass, blown sideways by winds exceeding 5,400 miles per hour. The planet's deep blue hue, similar to Earth's oceans, is caused by the scattering light of these silicate particles. However, the similarities to Earth end there. With surface temperatures reaching a scorching 1,700 degrees Fahrenheit, HD 189733b is a hostile and volatile world. The extreme winds and glass rain are driven by the planet's tight orbit around its host star, which is completed in just over 2 Earth days. This proximity subjects it to intense radiation and tidal forces, fueling its chaotic weather patterns. HD 189733b is a prime example of how alien and extreme weather can get on exoplanets. Studying this world offers scientists clues about atmospheric dynamics and helps refine techniques for detecting similar phenomena on distant planets. Ogle 2005 BLG 390lb, the coldest planet. Ogle 2005 BLG 390lb, located a staggering 21,500 light-years away, is one of the coldest exoplanets ever discovered. Dubbed the Hoth planet after the icy world in Star Wars, this frozen super-Earth exists in the far reaches of its host star's habitable zone. With surface temperatures plummeting to minus 370 degrees Fahrenheit, it's a desolate, icy wasteland. This frigid planet orbits a faint red dwarf star, which provides little heat and light. The planet's vast distance from its star results in an extremely long orbital period, taking about 10 Earth years to complete one revolution. Despite its cold environment, Ogle 2005 BLG 390lb's discovery was groundbreaking, as it was one of the first planets detected using gravitational microlensing. Its icy surface suggests that it could potentially harbor frozen water, sparking curiosity about its composition and the possibility of life beneath its frozen crust. While unlikely to be habitable, studying Ogle 2005 BLG 390lb has expanded our understanding of where planets can exist and thrive. This frozen world highlights the incredible range of environments exoplanets can offer, proving that even the most inhospitable conditions can yield fascinating discoveries. And there you have it, the 10 strangest exoplanets discovered so far. Each of these alien worlds challenges our understanding of the universe and expands our imagination. If you enjoyed this cosmic journey, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the extraordinary wonders of space. What if I told you the universe itself holds breathtaking wonders, spanning across light years, that defy imagination? From phenomena that warp time to structures so colossal they challenge our understanding of space. The cosmic web is home to some of the most awe-inspiring marvels ever discovered. Ready to unravel the mysteries of the cosmos? Join us as we explore 7 jaw-dropping wonders of the cosmic web. The Hercules Corona Borealis Great Wall. Imagine a structure so colossal that it takes your brain a moment to grasp its sheer size. A cosmic masterpiece stretching 10 billion light-years across. Meet the Hercules Corona Borealis Great Wall, the largest known structure in the universe. Now, when we talk about large, we're not just comparing it to planets or galaxies. We're talking about something so vast that light itself, the fastest thing we know, takes billions of years to travel its length. This isn't just a cluster of galaxies. It's a chain of galaxies bound together in a formation so massive it challenges everything we thought we knew about the cosmos. So how was this megastructure discovered? Astronomers were studying gamma-ray bursts, those incredible explosions that happen when massive stars die. And they noticed something strange. These bursts seemed to be clustered in specific regions of the sky, which hinted at the presence of a hidden cosmic giant. Further observations revealed this colossal wall of galaxies, stretching so far that it's nearly impossible to comprehend. It's like finding a mountain range that's